Hey everybody, Buzz Chucky here. Today I'm going to do a voltage drop demonstration, and I'm going to play with one of my new toys. I finally got the money saved up, and I bought a Picoscope from Auto Nerds. And I thought I would use it in the demonstration today. Also, I guess while I'm doing this, I'd like to say thanks to my parents, because they helped me out a little bit on getting the scope for me. So, thanks Dad, thanks Brenda, appreciate it. Anyway, let's get started. What I'm going to do is, I've got some resistors set up here. I've got them hooked up to my jump pack, as everybody has seen before. And what I'm going to do is, I'm going to do a simulation of a voltage drop where I put like 2 ohms of resistance going to the feed side, and I show you how the reaction is on the meter with the 2 ohms going to the feed. And then I also show a reaction of where I add another load to the system and show how the voltage drops when you add another load. And I also show you the same thing on the ground side. And the reason why I'm bringing this up is because I've seen this happen before, and it's thrown people off before, and they didn't understand what was going on, because if you have resistance in your positive feed before multiple loads, or in your ground after multiple loads, you can get intermittent problems where you'll be turning on a couple different loads like headlights, turn signals, whatever, and for like the first 2 loads you turn on, they're fine, everything works okay. However, when you start turning on more loads for that circuit that's in parallel with it, that share a feed, that share a ground, and you start turning on more loads, then that's when your symptom happens, and then it creates an excessive voltage drop, and then you get a whole bunch of weird things happening. You could get relays start clicking real fast, you could have engine hesitation, it could be making your fuel pump lose voltage, it could make your ignition coil lose primary feed voltage. There's a lot of different variables, so I'm just going to do a quick demonstration on what it looks like on the scope here, and that'll be it. So let's get started. I'm going to stay zoomed in on the scope while I'm doing the measurement, but just so you know, my first test is going to be on the feed side of the resistors. What I'm going to do is I'm going to show you what the voltage is without these 2 resistors in line, which equals 2 ohms. I'm going to show you the voltage drop without them. Then I'm going to put these in, show you the drop, and then I have this 8 ohm resistor that I've got ready to go, where I can put it onto the feed, create more current flow and more voltage drop. So that's what I'm going to do. So let me put you back on the scope, and we'll get going here. So let me get zoomed in so you can see it. There we go. I'll go about right there. Let's get it hooked up. And I'm gonna Okay, there we go. This is without any resistance in it. I got 12 volts on one load. $12 on the other load. And then I'll go on the ground side. And got about 40-50 millivolts on ground. That's the battery charger. So, but that's a good ground. Alright, now I'm going to put those two 1 ohm resistors in line before the feed to the other loads for an extra resistance of 2 ohms. Alright, gotta turn it back on. Main feed, 12 volts. Alright, after the resistor, I've got a drop. I've got about, looks about like 10 volts. Okay, so 10 volt, it's dropped a couple volts, 2 volts, with that resistance in there. So, you could have a normal operating condition with the vehicle, no problems, and you wouldn't know about it. But then, when you add another load on, say while you're going down the road, you turn on your headlights. Just a second, I'm moving my jumper lead. Alright. Alright, the beginning of the circuit, 12 before the resistance. Alright, now after the resistance, oh shoot, sorry about that. Laptop went blank there for a second. Let's do this again. Main resistance feed, but before the 2 ohms of resistance supply, you got 12 volts. After the two 1 ohm resistors, now it dropped down to, it looks about 7-8 volts. Okay, so now it dropped down even more. So now you only got 8 volts going to the rest of the components. So now I'm at the other load. So the other load got 8 volts. Go to another set of loads, 8 volts. And my simulated headlight load, 8 volts. Okay? So that's the demonstration on the positive side. Now what I'm going to do is I'm going to switch the jumpers around to the ground, and I'm going to show you what it looks like on the ground side. So just bear with me here for a sec. Alright, we're almost ready. There we go. Just going to do a quick check here, everybody. Okay, that's good. Alright, let me move the camera over here for a second and I'll show you what I did. Here I've got the two 1 ohm resistors. So then I just, here's the wire. It's tapped off the two, the two simulated loads. And then I've got this on the ground side now. Okay? Here's the red wire. Hands on it, and that's going to the ground lead. So now go back to the scope, and I know a lot of you are asking, well, why the heck are you using the scope to measure voltage drop? Well, because it's a new toy and I want to play with it. So it's really cool. I like it. And also, when I get done doing this last example, I'm going to show you something else kind of cool I think everybody will get a kick out of, so just hold on a sec. Alright, now, I'm doing my measurement on the main feed. Okay, main feed, about 12 volts. Okay. Now I'm going to go to the ground side. And on the ground side, with the 2 ohms of resistance in, I'm showing about, probably about 1.5 volts on the ground side, which isn't good. But now watch, when I put, I'm going to put an additional 8 ohms of resistance on the circuit. To create a bigger voltage drop. So like I said before, as you put more loads on, you have more current flow and you have more voltage drop. So now I'm going to go back on that ground side, and now on the ground side it's even higher. Now I've got like about almost 4 volts on the ground side. Probably about 3.5. It looks like. Yeah, 3.5 volts on the ground, and that's because of the additional resistance that's in the circuit on the ground because of the 2 ohms of resistance. So you put more loads on, you get more current flow, more voltage drop because of the loads and because of added additional resistance. I know it seems a little confusing at first, but it makes sense. The one thing I always say to myself to help me with this is more current flow, more voltage drop. Okay? Just keep that in your head and it'll help you remember, and it'll get you out of tough spots when you get stuck for a couple seconds. So here, let me shut that off for a sec. And now what I'm going to do is I'm going to take the 2 ohms of resistance out that I was using for that additional resistance. And now we're going to check this again. Now I've got 12 volts on the feed. Now on the ground, practically nothing. You got about 250 millivolts. So and that's it. That's what I wanted to show. So just keep that in mind. It'll help you out quite a bit when you're diagnosing intermittent problems You know, when a problem only happens like once in a blue moon. Well, there's always a reason for something happening. You just have to think about what's going on, and you need to think about what the driving conditions are, and, you know, ask whoever was driving it when it acted up, well, what were you doing when it acted up? And hopefully that'll help you isolate the problem. So anyway, for the end of the video here, like I said, I just got the Picoscope, and you all know that I like using the Load Pro. Well, I've got the Load Pro hooked up to this right now, and let me take off the leads here. You can use these leads on this scope. It's pretty cool. Like I said, if you're looking at the screen right now, and if you notice that the reading is just going all over the place, well, that's ghost voltage. See? Going all over the place. Now, when I touch the leads together, now it's still a little squiggly, but it's because it's on a very sensitive scale. But if you notice, now it's not jumping all over the place like it was before. So you got both leads together, and it's squiggling a little bit. I know that's a high-tech term, isn't it? Oh, let me get the lead here. As you see, wiggling the leads around, my reading, it's going all over the place. Now when I touch the two leads together, it's staying pretty steady on 0, even though you've got some oscillations. But it's not moving that much. Okay? Then what you can do is, you know, if you don't like the way that is, if you want to get it a little bit more steady, what you can do is just go over to your voltage ranges, go to 20 volts or 50 for a 24 volt system, click on that. Now if you notice, now it's a pretty steady line, and you don't see much noise in there. You really have to look close. It's kind of hard to see from the camera, but when I've got the leads together, it doesn't oscillate that much. Then if you wiggle them around, you notice that the line, it's moving. Leads together, stays steady. Now I've also figured out that let's see. It works pretty good at so far on slower time bases. So let's go at about 1 second a division. Okay. And if you notice there, alright, let me zoom in here because you can't really, there we go. Let the screen start again. Alright, see how it, the line is kind of thicker? Right now, because that's ghost voltage and I'm getting spikes. Now, if I put the leads together, watch the line. See, it got smaller, not as fuzzy. I got both leads together, so that's showing continuity, true 0 volts. Or if you're checking something at a load component, that means you have a short to ground. So I'm still experimenting with it. It seems to work better on the lower time scales, but it does work. You can use it with a scope. I think it's pretty cool. Let me try a faster time base and see what we get. That's way too fast. The other cool thing about this scope is, what I like is the sample rate is adjustable, which is really cool. Depends on what time base you're at. It'll only let you do so much, but I do like being able to adjust it. So 50, no, did not want that. Like I said, you gotta adjust it a little bit. I'm gonna go 2 seconds a division now. And then I'll go to auto range. Okay. As you can see, the line got smaller. Now you gotta let it go the entire screen and let it auto range, because it's on a slower time scale. If you notice, the voltage went from it was like a 20 volt screen, now it went to a 2 volt screen. And as you can see, now I'm getting lots of ghost voltage because I'm on a lower voltage screen. Now I'm getting a whole bunch. So if you start out in auto, start out in auto range first, and if you notice, I've got the leads open, wiggling around. That's ghost voltage, and as you can see, there's a lot of noise, there's a lot of hash. Okay, so now watch what happens when I put the leads together. Look at that. Not nearly as much, and then if you shake them around, you're not going to have as much noise. So true 0 volts, short the ground, then you let off, and ooh, more hash, more noise. So you can use the Load Pro leads with a scope. They will work. The only thing that you will probably need, depending on what type of scope you have, you might need a banana adapter input, and they're cheap, you can get them. Or if you just got straight banana plugs, these are banana plugs, so they'll work that way too. Anyway, I thought I'd share the voltage drops, with dealing with multiple loads, and then show you my new toy and see what everybody thought about it. So, but anyway, I'm having a blast. Really liking the Picoscope. Like I said before, I bought it from Tom Roberts at autonerds.com, and this scope it's unbelievable. You would be amazed what you can do with this thing, and I have just started learning how to use it, and I'm not even at the tip of the iceberg yet with this thing. It can do so many things. It can sample very fast. It has a gigantic buffer in it, which means that you can store an enormous amount of data that you can scroll over later to review. For example, let's just say if you wanted to look at this screen that's going right now, let's just put these leads together for a second. And for the true 0 volt, I'm going to stop the scope. Okay, I stopped it. Now what I'm going to do is I'm going to zoom in on this thing. Go up to the magnifying glass. want to zoom in on it. Check that out. I can even zoom in even more if I want to. So that just shows you right there, what you can do with this scope to examine things. And you can filter the signal. There it is, filtered at 8 Hertz, and you can adjust it. Depending on how much you want and everything. So anyway, it's a very cool scope. I'm hoping to later on actually do some scope videos showing, basic setup and stuff like that. I'm not an expert yet by any means, but I am willing to share what I know so far and what I've figured out. So, because like I said, I just got it. I'm just starting to learn how to use it. I have some prior scope experience, but not that much. I've only been using scopes now for, hands-on, maybe like a year or so. So I'm still learning, but I'm enjoying it. And like I said, I'll try to do some scope videos for everybody, and I'll try to do some more training to electrical, and we'll go from there. Sorry I haven't posted of late. It's just I've been busy. Like I said before, I'm a busy guy. I work full time and don't have a lot of spare time to do stuff. So, but I finally had some time to do this and to show everyone. So, I hope everybody enjoys it. And if you have any questions about anything on the video, please let me know, and I'll be more than happy to answer them. So, everybody, have a good night. Goodbye.